sine squared theta times cosine theta equal to cosine theta. Here's I see something interesting about this problem. Here's a very common mistake that I've seen over and over when people try to solve the problem. The first thing a lot of students did was what? Divide both sides by cosine theta. And I claim it's not okay doing that, because whenever you want to multiply and divide by a number, you want to make sure that that number is non-zero. Okay? What if cosine is 0 and you cannot divide both sides? It means that if you divide, you are missing some solution. So what I would do is bring everything to one side. Sine squared theta times cosine theta minus cosine theta equal to 0. See, I did not divide anything. Now I'm going to factor out cosine theta. I got what? Sine squared theta minus 1 equal to 0. Okay, now I got brought up two factors equal to 0. I can solve it. Either cosine of theta equal to 0 or sine squared theta equal to 1. So we start with the first case. Cosine of theta equal to 0, then you ask yourself the same old question, what angle make cosine equal to 0? Oh, by the way, let me check. Oh, same thing. The angle is theta between 0 to 2 pi. It depends on problem. If they give you different restriction, then you have different answer. And here, usually it's 0 to 2 pi. Cosine theta equal to 0, you ask yourself what angle make cosine equal to 0? Pi over 2 and 3 pi over 2. So in general, theta equal to pi over 2 plus k pi, right? Pi over 2, keep adding pi, keep adding pi. Okay? And with that condition right here, I only have two good solutions. Theta equal to pi over 2 and 3 pi over 2. And then, second one right here, sine squared theta equal to 1, we have two cases. Either sine theta equal to 1 or sine theta equal to -1. So actually we have three equations to worry about. Sine theta equal to 1, and then we got to talk about sine theta equal to -1. Start with 1. And same old question, what angle makes sine equal to 1? Sine equal to 1 is right here. Okay, so, and then keep adding 2 pi. So theta equal to pi over 2 plus k2 pi. And within that unit circle, 0 to 2 pi, we only have one solution, pi over 2. Excuse me. Third case, sine theta equal to -1 right here. So theta is going to be equal to negative pi over 2. Negative pi over 2 right here, plus 2 pi, plus k2 pi. And negative pi over 2 is not in the interval. So you have to add another circle, 2 pi. Negative pi over 2 plus 2 pi is 3 pi over 2. So theta here equal to 3 pi over 2. It's fall into that interval. So you have how many solutions? 1, 2, really 2 solutions. Okay, that's how you solve for trig identity. Now let me look at some exercises on 6.3. Still trig equation, but they're gonna increase the level of difficulty. They're gonna make the equation becomes harder. So I'll look for a harder one. All right, 2 cosine of 2x equal to -1. Now we don't just work with a single angle anymore. You may have double angle. Two cosine of 2x equal to -1. And x is, again, they just put it from 0 to 2 pi as standard. Alright? So how do you solve it? I see that I have the angle of 2x, but only have one trig function. So divide both sides by 2. Cosine of 2x equal to -1/2. Now you ask yourself, what angle make cosine equal to -1/2? Cosine equal to -1/2 is going to be right here. This is 30 degrees, so pi over 6 plus pi over 2, so 30 degrees, so 2 pi over 3. Okay, so 2x is equal to 2 pi over 3. This one, and of course, keep adding 2 pi plus k2 pi. But that's not the only answer. You may have the angle right here. Okay, opposite of this, still cosine equal to 1/2, so 2x could be equal to what? This is 2 pi over 3, so 4 pi over 3. And again, plus k2 pi. Okay, and if you don't feel comfortable with pi, then you can think of degree. This angle is what? 120 degree. From here, it's 120 degree. The angle from here to here is 240 degree. Okay, and this is for 2x. And what do you do to solve for x? You divide both sides by 2. Okay, this one, you have x is pi over 3 plus k pi. This one gives you x equal to 2 pi over 3 plus k pi. Okay? Now, you make sure that x is between 0 and 2 pi, so you have to check. Okay, and this is how. First one, pi over 3. Pi over 3 is 60 degree, right here. And then plus k pi, so you got 60 degree right here, plus 1 pi right here, and then keep going pi. Okay, so you'll have two possible solutions when x is between 0 and 360. This one right here, 60 degrees is pi over 3. And then the point right here, all the way here. So pi over 3 plus another pi over 3, so 4 pi over 3. You have two solutions, x equal to pi over 3 and 4 pi over 3. Keep adding pi. Okay. If you add one more, it's going to go outside of the interval of 2 pi. Second one, x equal to 2 pi over 3 is going to be, let me draw another circle there. 2 pi over 3 is right here. 2 pi over 3. Okay? 2 pi over 3. You keep adding pi. So here, adding pi, you have another one right here. So you also on the solution. So x is equal to 2 pi over 3, and then add another 1 pi, so you got 5 pi over 3. So you're going to have a couple solutions. Pi over 3, 4 pi over 3, 2 pi over 3, and 5 pi over 3. 4 solutions for that one. So yeah, this example, I try to bring to you something. First of all, you try to solve whatever angle you have for the trig function. In here, I solve for 2x, right? Then I'm dividing both sides by 2 and solve x. And I got the general solution for x is pi over 3 plus a multiple of pi, or x equal to 2 pi over 3 plus a multiple of pi. And then I look at the condition they have from the beginning. X is somewhere between 0 to 2 pi, one complete circle. So I draw the graph, and what angle that make complete within 0 to 2 pi. Pi over 3 is right here, plus another pi, good. Plus another pi, no good. Just two solution. Similarly, 2 pi over 3 right here, plus 1 pi, still good. But another pi, let's go outside of 2 pi circle. Start from here and go all the way to here and cannot go any further. To make sure that you guys understand it, I'm going to change the condition. What if my solution is somewhere between x to 4 pi? Then how many solutions I'm going to have? First one right here, pi over 3, right? Keep adding pi. So 4 pi means what? Start from 0 right here and go all the way to one circle, which is 2 pi, and then can go another circle, 4 pi's. You have what? Pi over 3 right here. And then go 1 pi. You got 4 pi over 3, still good, right? Add another circle, still good. 7 pi over 3. One more circle, still good. And then 10 pi over 3. You have 4 solutions in here. And similarly, you do the same thing with the second one. So it depends on the condition that they give you. If they don't give you any condition, this is how you answer it. You have a lot of solutions. This is what. Without this restriction for the domain of x, then you have infinitely many solutions. There's pi over 3 plus a multiple pi, 2 pi over 3 plus a multiple pi. Okay, try another one. I think it's 2 sine theta equal to 2 cosine 2 theta. 2 cosine 2 theta. So obviously I see a 2 here, I see a 2 there, I can cancel out right away. So what is the point of putting a 2 here? I have no idea. Let me make sure that I copy it right. Yeah, I don't even need the 2 here. I don't need the 2 here. So I see that ask to solve for theta, and the left hand side is sine theta, the right hand side is 2 cosine theta, and the angle is no restriction. Okay, fine, no restriction. Okay, so I see on the left we have the single angle theta. On the right hand side you got double angle. First thing I would do is try to bring the double angle down to single angle. So I look for the double angle formula, cosine of 2 theta, and of course match up with the sine, so I'm going to use this one. This is sine theta, right? Cosine of 2 theta, right and left. We have 3 equations. Cosine square theta minus sine square theta. I got 2 cosine square theta minus 1. I got 1 minus 2 sine square theta. Among the 3 equations, I'm going to use the third one. You guys see why? Because I only have sine function in here. If I use the first one, I have sine and cosine. The second one, I have sine on the left and cosine on the right. So the third one will be the best. 1 minus 2 sine square theta. Now, I see a quadratic, so bring everything to the left, 0 on the right. 2 sine square theta plus sine theta minus 1 equal to 0. Quadratic. Okay, then quadratic equation or just factor, I think it's factorable. 2 sine theta something, and then sine theta, I think plus 1 here, minus 1 here, let's check it out. Sine 2 sine theta times sine theta, 2 sine square theta, 2 sine theta minus 1 sine theta, yes, that's right, equal to 0. And now you solve like normal. The first one means what? Sine theta equal to 1/2. Second one means sine theta equal to 0. Oh, might equal -1, I'm sorry. Then what angle makes sine equal to 1/2? 1/2 is right here, so theta equal to pi over 3 plus k2 pi, or theta equal to another one right here, so what, 5 pi over 3 plus k2 pi. I think it's pi over 6. Pi over 6, 5 pi over 6. Okay, and sine equal to -1. -1 is right here, so theta is equal to negative pi over 2 plus k2 pi. And k could be 1, 2, 3, 4, 5 negative numbers as well, 0 as well. You have the solution. Okay, so hopefully with a couple of examples, it's helped you to get some ideas of how to solve or trig equation, including the trig inverse function equation as well. And the technique I'm showing you will not be everything, obviously, because there's no way it can cover everything. It's a different problem. You have different way of solving. But via example, hopefully get you the main idea of how to solve. And of course, if you have any question or you face any difficulty of solving, please don't hesitate to email me. I'm here to help. Thank you, guys.